Okay, well, welcome to lecture 3.4. Okay, now I'm about to start trying to write out these P terms, write them out as a function of NS, ND, theta S, and theta D. Okay, now to do that, we're going to go back to some of the things that I did in lecture 2.10. I'm almost certain that's the number. So, anyway, from session 2, I talked about, I said, okay, here's a little taste of what we're going to do, some of the hard parts of the Levitt Porter paper. Here's a quick review. We had a bunch of these terms. Okay, it's useful to calculate all the different ways there can be a crash. Okay, if one way a crash can occur is if both drivers were sober and there's a crash. Another way, both drivers were drunk and there's a crash. Third way is the eastbound driver was sober, westbound driver was drunk, and there was a crash. Fourth way, the opposite. Eastbound driver was drunk and the westbound driver was sober. Maybe I reversed those. Anyway, we would like to, and then the probability of crash is the sum of those four terms. So let's calculate each of those four terms. Okay, so the first one is the probability eastbound driver is sober and westbound driver is sober, and there's a crash. It equals this term. Okay, so this is just so these events are actually independent. So the probability of all of this is just the probability the eastbound driver is sober. That's that term, times the probability the westbound driver is sober, which is that term, and the probability there's a crash. Yeah, you know what? That's given a crash given eastbound driver sober and the westbound driver is sober. And I wrote that as theta S plus theta S. It's actually not quite right. There's an interaction term. I think if I remember right, it was minus theta S squared. Levitt and Porter said those theta terms are so small that we can ignore those interaction terms. I'm not 100% certain that's correct. I'm willing to give them the benefit of the doubt, and I'll proceed with the paper as if it's true, but I think that may be a good dissertation chapter. I think a publishable paper to say, what if we re-examine one of the assumptions of the Levitt Porter paper and see how sensitive their results were to that assumption? What if we put in what I think is the more accurate assumption, see if the results really change? Okay. So regardless, that's what we get. Okay. And then something else, probability eastbound is sober, westbound is drunk in a crash equals this term. Okay, and so on. We get all those four terms. Now, next, I'm going to write in the next board, I've already written this, I want to write the probability of a crash. The probability of a crash is just the sum of these four terms. Okay, so hopefully you're doing this on your own with pen and paper, verifying that if you do I'll call it arithmetic. It's a little bit hard arithmetic. It's at least, I think, algebra 2 level type math. If you do that math, you, collect terms, get probability crash equals this. Okay. Once we have that, once we have the probability of crash, we can start calculating these p terms. So, for instance, PSS, that was defined to be given a crash, the probability both drivers were sober. Okay, so that is going to be the probability eastbound driver sober and westbound driver sober given a crash. Bayes' law says that we can rewrite this term as this. It's probability eastbound driver is S, westbound driver is S, and a crash occurs divided by the probability of a crash. Okay, now, probability eastbound sober, westbound sober. So if we take this term, divide it by the probability of a crash, which is this term, okay, we're going to get this, okay, this term divided by probability of crash. Um, and that is all going to simplify to this term. Okay, so that is PSS. I'm going to rewrite it in a second on another board. Okay, but next thing I want to do is talk about. All right, you know what? I'm probably stating this wrong for a lot of cases. I think I said we want the probability PSD. It's actually, I think, what Levitt and Porter, they always called it PDS. I'm calling it PSD. That was wrong. When I say PSD, that's wrong. There is no PSD. PDS, that's just the definition that is defined to be the probability that exactly one driver was drunk given a crash. Okay. All right. Now, I made a big deal. I said it was easier to think of this as a road. There's an eastbound driver and a westbound driver. Okay. Given that, okay, there's two ways that you can have exactly one driver being drunk. You can have the eastbound driver being drunk, westbound sober, or the opposite. Okay. So, probability exactly one driver was drunk given a crash, which is that. This equals that, what I just told you. And that equals probability. Okay. So, probability eastbound driver sober, westbound driver is drunk given a crash. Okay. From those last two boards, you should be able to substitute in those terms, and you get one term like this. It's probability eastbound sober, westbound's drunk. Now, it turns out the opposite one, the one eastbound driver's drunk, westbound sober, is exactly the same. It should be. Like, there's nothing magical about going east or west. You know, the opposite case should equal that exact same probability. So we just multiply that by 2. We should get the probability that exactly one driver was drunk. Okay. And then the final thing is we're going to have a similar probability term, PDD, the probability that both drivers were drunk. And I'm going to explain that. I'm going to write a new board. I'm going to write all those terms all on the same board. And that will be, oh my gosh, I've already forgotten which lecture I'm on. This is 3.4, so that will be in 3.5. Okay, see you there in lecture 3.5.